Hello, boys and girls. This is Mr. Kizik, and this video here, we're going to be looking at multiplying binomials here. So if you remember in the very beginning of the year, we talked about combining like terms with polynomials, and that was adding and subtracting. And then we did talk about multiplying or using distribution when we had one term on the outside of the parentheses and multiplying across the parentheses. We haven't really talked about, though, what happens if I have two things in the parentheses multiplied by two things in the parentheses, or later on we're going to be looking at 2 with 3. You may have heard this term before. It's called the FOIL method. Now, don't really like teaching as FOIL because when we get to problems where it has more than two things in parentheses, how do you do it? But really what FOIL is, as the picture is shown here, you multiply the first terms together in the parentheses, and then you multiply the outer terms in the parentheses, you multiply the inner terms of the parentheses, and then you multiply the last terms. So if I look here as example 1, using FOIL, x times x. What is x times x? That would be x squared. Now the O part, the outer terms, do x times 4, which is 4x. 2 times x, 2x. 2 times 4, 8. And then at the very end, what you want to do is you want to multiply or combine like terms in order to get it into standard form and to simplify it. So do I have any like terms here? Well, yes, I do. I have a like term here and here. So if I combine those two, if I add them, x squared plus 4 plus 2, 6x plus 8. And this, ladies and gentlemen, will be the standard form of way of writing it, where you have the highest exponent first and then the next lowest and lowest after that. And that's really it here. So let's just look at a couple. I'm not going to do all of these here, obviously. So if I look at, I want to do number 1 here. Let's look at number 2. So we do the first terms here, multiply those two. K times k. K squared. Then I do k times 5. Which is going to be 5k. Then we have negative 4 times k, which is negative 4k, and negative 4 times 5 is negative 20. See if you can combine anything, which I can, these two right here. So I'm left with k squared plus k minus 20. And that's it. I'm just going to go all over the place here. So let's look at something like number 5. We multiply the first terms together, so 4x times x, there you go, be 4x squared. 4x times positive 3, which would be 12x. Negative 7 times x, negative 7x. Negative 7 times positive 3, minus 21. Combine like terms, so I have 4x squared plus 5x minus 21. Okay. And that's really how you multiply a binomial with a binomial. There's really nothing more difficult about it. One thing I want to just show right now, I'm just make sure it's not later on here. Okay. There are a couple problems actually I want to do in a little bit, but if I had like number 5 here, I'm going to rewrite number 5 with a subtle difference. What is the difference between what I just wrote and number 5? Well, the difference is, notice how I have something between the parentheses here where there's nothing between the parentheses here. When there's nothing between the parentheses, just like in number 5 here, that means multiplication. Whereas here, I do have something. I have an actual operation, add or subtract. So in this case here, you don't multiply. You don't do 4x times x. You would just combine like terms. 4x plus x, 5x, negative 7 plus 3, negative 4. That is the difference between those two. So I just want to make you aware of, if I see either one. All right, let's look at, okay, I like those there. Let's look at something like number 11 here. So it's still a binomial multiplied by a binomial. So I'm just going to do 5x times x 5x squared. 5x times negative y is negative 5xy. Right, I can't multiply the x and y. It's not going to become x squared or anything like that. It's just xy. 4y times x, 4xy. 4y times negative y is negative 4y squared. And now I'm just going to combine any like terms and then simplify. So negative 5xy plus 4xy is negative xy. And that's it. Nothing else can combine there. All right, let's look at number 15. X plus 4, that quantity squared. What do you think that means? Or, no, let's look at an example here. If I told you 3 squared, yes, we know 3 squared is 9, but what does that really mean? How can I expand that? Well, 3 squared is the same thing as saying 3 times 3. It's a thing multiplied by itself. So here, it's the same thing. X plus 4, that quantity squared, is the same thing as x plus 4 times x plus 4. It is not, and in fact, only put in red, so we just say that's bad. It is not this. Definitely not that. Okay, so with this here, you just do the same thing. X times x, x squared. X times 4, 4x. 4 times x, 4x. 4 times 4, 16. Combine like terms, and I'm going to have x squared plus 8x plus 16. Okay, so whenever I have something like that, it just means you take that whole parentheses and you multiply it again. All right, let's look at the last part here, the last part, where we want to multiply a binomial by a trinomial. So notice FOIL, you could see me right now, I'm using quotes here, does not work because FOIL only works for binomial times a binomial. But it does the same concept. You take the first thing in your first parentheses, so like this x here in number 19, and you multiply it with everything across the other parentheses. So x times x squared, x cubed. X times 3x, 3x squared. X times negative 6, negative 6x. And then I do the same thing with the 4. 4 times x squared, 4x squared. 4 times 3x, 12x. 4 times negative 6, negative 24. And then combine things at the very end. X cubed, nothing to combine with. But this 3x squared and 4x squared combined to give me 7x squared. Negative 6x and 12x gives me 6x. And negative 24 comes along to the right. All right. Let's just look at another one just to see. So for 21, 3a times 5a squared, 15a cubed. 3a times 2a, 6a squared. 3a times negative 6, negative 18a. 1 times 5a squared, 5a squared. 1 times 2a, 2a. 1 times negative 6, negative 6. Combine like terms. 6a squared combines with 5a squared to make 11a squared. Negative 18a combines with 2a gives me negative 16a. And then minus 6. That's why math teachers really don't like to teach the quote-unquote FOIL method, because when we get to something like this, students are like, well, it can't work, so therefore do I just keep leaving it alone? All right, let's look at number 23, which could be an example of a keystone type problem here. So if I look, it says find the area of the shaded region as a simplified expression. So in order to do that, let's just think about the concept for a minute. How would I find the shaded region? Well, hopefully you're thinking that, well, I have to find the area of the outside. So the area of the outside minus the area of the inside would equal the shaded region, right? Because if I had the whole thing, I took away the part that is not shaded, I'm left with shaded. So how do I write that here? Well, remember, the area of a rectangle is length times width or base times height. So what's the area of the outside rectangle? Well, the area is the length, 9x minus 2, times the width, 2x plus 7, minus the inside rectangle, 3x times x plus 12. And wherever our answer is going to be is going to equal the shaded region. So I'm not solving for x or anything, we're just leaving it in terms of a polynomial. So here, I'd have to use FOIL, so 9 times 2x, 9x times 2x, 18x squared, 9x times 7, 63x, negative 2 times 2x, negative 4x, negative 2 times 7, negative 14. And then here, this is just a monomial or one term multiplied across parentheses. So negative 3x times x is negative 3x squared. And negative 3x times 12 is negative 36x. And then here it's just a matter of combining like terms. So combine all the x squared terms, which is going to be 15x squared. 63x minus 4x minus 36x. So I would have, what is that, 23x? And then minus 14. And that's it. Like I said, you're not solving for anything here. You're just making it in the simplified form. All right, so make sure you do understand number 23 here, because that could be a good question that is on the keystones here. All right, for your homework here, what do I want you to do? What do I want you to do? There's a lot of examples, and you know what? I like it. Let's do the odds, all right? So do the odd problems, all of them from 1 through 25. Yeah, 1 through 25 here. And, yeah. And if you got any questions or concerns, please feel free to email me or ask questions